Hello Legacy students. Today we're going to look at factoring polynomials, which is basically factoring like we were doing with quadratics, but it's back and it's bigger than ever. So remember that factoring foldable that we made on during unit 6. You're going to want to make sure you find that, keep that in your mind. That's what we're actually going to be using. We're going to be using the same methods to factor. However, it's going to be a little different of problems. So remember, factoring basically means to break apart into little parts being multiplied. So factoring, if you want to think of it, is undoing multiplication. So at the end of any factoring problem, what we can do is actually multiply it back out to get the original. It should always work that way. Now, your strategies are going to be the same, like I was mentioning, but your answers and how these problems are going to look are going to be different than what we were dealing with, just because we're dealing with higher order polynomials, aka to the fourths, to the thirds, to the fifths, stuff like that. So the first kind we want to look at is greatest common factor. Now, you need to take out a greatest common factor first. Always, always, always check, because this makes it 10 times easier when you are factoring. It makes your problem simpler, makes the numbers easier, stuff like that. So right now, I have 50x to the fourth minus 25x to the second. Now, it's two terms, right? There's two pieces to this puzzle. So either I know that I can have a difference of two squares or just a GCF. Well, notice 25 is not a difference of squares. Or 50, is not a perfect square. So I can't use difference of perfect squares on this problem. Let's see if there's a greatest common factor. Well, 50 and 25, I think they share a number. And I'm pretty sure they both can have a 25 divided away, right? Now, what about my x's? I have 4 x's here, and I have 2 x's here. Well, at most, both of them have 2 x's. So I'm going to take an x squared out of both of them. Basically, I'm going to divide away an x squared. So let's divide both of these pieces by 25x squared on both of them. Okay, 50 divided by 25, well, that's just 2. Now I have 2 x's down here, 4 x's up there. So I'll be left with just 2 x's on the top. And then 25 divided by 25 is 1. My x's, I had 2 x's on the bottom, 2 x's on the top. They're going to cancel away. So I'm left with 2x squared minus 1. Now, this is going to be something very common now when we're doing with polynomials of higher order. You always need to check, can something simplify further? So I have 2 pieces here, 2 terms. So it would have to be difference of 2 squares. They're not perfect squares. So this is a done problem. But you're always going to want to ask, am I done? Am I done? Because there will become problems where you could go for a few more simplifications, and you need to make sure you simplify until you can't simplify any further with factoring, okay? Now, group factoring. Group factoring is only when you have 4 terms. This is only when you can use this. You can't use group factoring when there's 3 terms or 2 terms. You can only use it when it's 4 terms. 4 terms now. Group factoring. Oh, hold on. Before I do that, do I have a perfect square or a GCF that can come out? Because you always remember, gotta check for that GCF. 30, 18, 25, and 15. It doesn't look like there's anything that can come out of that. So it looks like I'm okay there. So now let's start our group factoring. So I'm going to make my box here. Whoa, that was a really bad box. That's okay. Got 30x cubed minus 18x squared minus 25x and 15. Now, what number can 30 and 18 share? That's the biggest number they share. Let's think that way. Well, they share 2. They share 3. What about 6? They both share a 6. Let's see if 6 is going to work. Now, how many x's? These guys has 3 x's. This guy has 2 x's. So they both share 2 x's, right? Now, here's when I can start asking multiplication questions. 6 times something right here has to give me 30. Okay? So 6 times what gives me 30? Well, that's just 5, right? X squared times something right here needs to give me x cubed. Well, I still need one more x, right? So I'll have an x left behind. Now, let's keep going. 5x times what, right here, will give me negative 25x. Well, 5 times negative 5 will give me negative 25, right? And I already have an x. Another way to look at that, what do these guys have in common? Well, they have a 5. I know a lot of you have trouble figuring out when is that negative? When should I put a negative? I think the easiest way is to think about your multiplication to make sure you get that multiplication to turn out your negative. Now, negative 5 times what will give us this 15? Because you see how those two kind of meet up together to make that 15? Well, I know that needs to be negative 3. Let's check the multiplication though. 6x squared times negative 3 does in fact give me that negative 18x squared. So now I can write my 2 pieces that came out of my box. There we go. So then each of these pieces here are known as my factors. These are the factors of this particular problem. So if I'll multiply this back out, I should and will get that right there, the problem we started with. Now, as I said, check. Did we factor all the way? Can I simplify either of those yet? So there's 2 pieces. Do they have a GCF? Do they have perfect squares? Doesn't look like it. So that's done. That is my done answer. 5x minus 3 times 6x squared minus 5. Trinomials in quadratic form. So basically what this means is I'm going to have something with a 4 or a 6 or a 2 or an 8, something like that at the front. So this one I have 2x squared minus 5x minus 12. So this is a trinomial. When you see a trinomial, aka 3 pieces, okay, you're going to use your AC method to find out, to get your group factoring. Because you got to get 4 pieces to group, right? So let's use our AC method. 2 times negative 12 is negative 24. Now, let's list all the possible ways to make 24. 2 and negative 12, negative 2 and 12, negative 8 and 3, negative 3 and 8, negative 6 and 4, negative 4 and 6. Think that's about it. And then 1 and 24 as well. Well, I need these numbers to make me this negative 5 in the middle, which looks like my negative 8 plus 3 will give me that negative 5, right? So let's rewrite this problem. 2x squared minus 8x plus 3x minus 12 equals 0. Oh, not equals 0. I don't know where that came out of. Okay, now notice 4 terms. 1, 2, 3, 4. I can now group. So now what I'm going to do, build my box, put each of these pieces inside. I noticed a lot of you try to put that negative 24 somewhere. Don't do that. Just put what you see here, because this is that problem. You just kind of change the answer to make it work for you. So it looks like we have a 2x that can come out of here. 2x times just x will give me 2x squared. X times 3 will give me 3x. And 3 times negative 4 will give me negative 12. 2x times negative 4 is negative 8x. So let's write our factors now. Let's double check. Does anything come out of these two? Because realize I forgot to check my GCF again. Well, doesn't look like anything can come out of either of those, so I'm lucky. Nothing got no issues there. Let's look at one with a higher order here. So notice this one's x to the 6th. So first things first, check for a GCF. Do 4, -20, and 24 have anything in common at all? You know what? I think they do. They have a 4 in common. So let's yank that out. It's going to make our math 10 times easier. Notice, too, this one has an x to the 6th, an x to the 4th, and an x to the 2nd. It looks like they all have 2 x's in common, right? So let's yank that out as well. So let's divide all of these by 4x squared. Okay? Well, the 4's are going to cancel out, leaving me a 1. So I'm going to be x to the 4th, -5 there, with 2 x's left behind, and a +6. X's are going to cancel out, right? So now, this is just going to kind of hang around, come along for the ride until the end of our problem. So I have 3 terms, so we need to do AC, because AC means 3 terms. So 6 times 1 is 6, and I think a -6 and a 1 will give me a -5, but that won't give me a +6, so that can't work. What about -2 and -3? That should give me -5. So let's go ahead and rewrite that inside here. Don't forget that x squared on both of these, because -2x squared minus 3x squared is -5x squared. It looks like I can box that inside now. So that 4x squared, like I said, he's just going to hang around in the front, not worry about nothing. He's just going to come along for a ride. There we go. So these two have an x squared in common. Notice, because this one's x to the 4th. This then, x squared times x squared gives me x to the 4th. These two, it looks like they have a 3. So I'm going to do a -3. So then -3 times x squared will give me -3x squared. And then -3 times -2 will give me a 6. So let's rewrite our factors. X squared minus 2. X squared minus 3. Now, do these two, I notice they're squares, right? So are they perfect squares, 2 and 3? They're not. So this guy does not break down any farther. Be very, very careful. That will happen. I know it will. So you always want to ask yourself, am I done? Am I done? Because you're going to catch problems that will simplify further. Now, don't forget about the difference of perfect squares one. That one was the simplest one, but a lot of people have issues trying to remember this one. So that was the one where we had those 2 parentheses. One had a plus, one had a minus, and then we had stuff on the inside were the exact same thing. So it had the numbers here. It was their perfect roots, right? The square roots. So 16, its square root is 4, so I'm going to have a 4 here and there. But now notice, he's x to the 4th, so x and x will just give me x squared, right, if I multiply? So what if I just go x squared, right? Because x squared and x squared gives me x to the 4th. 81 now, well, that's just 9 if I break it down. But now, notice, am I done? 4x squared plus 9 and 4x squared minus 9. Well, 4 and 9 are both different, cubes, or squares, excuse me. And I have a subtraction sign here. This second piece here can break down, not the first piece because he has a plus, but this second piece, let's break him down further. So I still have that 4x squared plus 9, but that other piece now can be broken into its own 2 parentheses. So I'll have a plus and a minus, and then it's going to follow the same pattern. So 2x and 2x, because if I multiply that, that's 2 times 2, 4. X times x, x squared. And then 3 and 3 should give me a 9. Now, let's double check. Are we done yet? Well, this side doesn't break down. We already assumed that. That doesn't break, and neither does that. So it looks like we are finally finished with this problem. So now, just some things to keep in mind. Always, 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 always check that GCF. Find it. Make sure it's not there, because it's going to make your problem 10 times easier. If there's not a GCF, or even if there was, then you can use your group factoring, which is when you have the 4 terms. Remember, if your A is 1, AC is not necessary. And we're going to talk a little bit about that in class when you get back after this video. And then the difference of 2 squares. That's when you have to have 2 terms, has to be subtraction, and they have to be perfect squares. Otherwise, that one does not work. Alright? And that's the end of this video. See you later, Savers.